All right, here we go. So 8.2, graphing sines and cosines. So we've never seen the graphs of sines and cosines. They're very cool. This is pretty much what the rest of this chapter is going to be on, is how to graph sines, cosines, and then we'll do tangent, cotangent, and then secant and cosecant as well. Okay, so we'll graph all 6 of them. We're going to graph them by hand. This is pretty much all no calculator from here on out. Okay? So first of all, we have to look at sine and cosine are what we call periodic functions. So they are functions. Okay, they pass the vertical line test, but they're functions that have a certain period. They also have a thing called an amplitude. So we're going to talk about those 2 definitions first. All right, so a periodic function is basically a function that's going to repeat after a certain period of time. Okay, so looking at this function, it's like this little mountain, and then another mountain, and another mountain, and another mountain. Each period is defined as, right, the space before it starts to repeat again. Okay, that would be 1 period. Okay, and this is sort of the formal definition. There's a p greater than 0, such that x of f plus p equals f of x for all x. The smallest number p is called the period. So from here, if it goes from -8 to -4, what is the length of that period?
4.
Yeah, so 4 would just be the length of my period. Nice and easy. How about for this one? This graph's a little different. It's kind of like a curve. It comes down and goes back up and comes down. So you want to find 1 period in there before it starts repeating again. So do you guys see it? How long would the period be? I don't know what these are. Sorry. This is a typo. The pi should be here and 2 pi should be there. Okay, there we go. They were floating in the air. Sorry about that. So how long would be 1 period before it repeats? 2 pi. Yeah, you're going from -2 pi all the way. You want to go down and back up again. So the length of this period would be 2 pi. Okay? And we're going to do most of our graphing here is going to be in radians, so you're going to get used to using the pi's, the pi over 2's, the 2 pi's, all that stuff. All right, what's the questions on period? Make sense? 1 period is before the wavelength repeats again. All right, amplitude.
This is different.
Is it? Good. I'm glad it's coming all together.
It's not a good thing.
All right, amplitude. An amplitude, by definition, is the maximum divided by the minimum minus the minimum, thank you. Maximum minus the minimum divided by 2. Okay? So this is technically your definition for amplitude. Basically what the amplitude is it's the height. Okay? So it's the height from the middle point of your graph. So if I look at what my maximum is, my minimum value, and I divide it by 2. So what is the maximum value of these mountains? 3. So I would take maximum minus minimum divided by 2. So I take 3. What's the minimum value? 0. Remember, we're always looking at y values here, guys. Always looking at y values. And then divide that in half. So our amplitude would be 1.5. Another way to do it when you're looking at the graph is to draw a sort of imaginary horizontal line down the middle. And you're looking at from that middle, how far is it to the top? Or how far is it to the bottom, right? And so it's 1.5 to the top, and it's 1.5 to the bottom. So your amplitude is just 1.5, yeah.
Do you always want it as a decimal?
No, it could be a fraction for sure. You could leave it as 3/2, that's fine. All right. For this one, since it's straddling the x-axis there, that's kind of your middle, right? And so if we go up, oh, there's no numbers here. Again, sorry about that. And this should be pi and 2 pi. Whoops. Okay. There's nothing marked. This is +1, sorry, and this is -1. So what's my amplitude? +1, yeah, good. Your amplitude is always going to be positive since you take the difference of those and divide by 2, right? And so that difference would be a positive difference, right? We do 1 minus -1, okay, and so you get 1. All right, so again, it's just sort of the halfway measure. That's your amplitude. Questions about amplitude? It's not the whole height. It's basically half of your height. Okay? All right, so now let's actually graph these. Ready for sine and cosine? And this is what your quiz is on tomorrow. to be able to graph these. You have
this
to.
exact thing and you have a minute to fill it out.
No. It's not. You don't have all this. You just have this. I'll talk more about the quiz in a minute. But let's first start filling this out, okay? So here we go. We want to complete the chart first just to figure out some basic points, and then I'll talk about how you're going to actually graph them. So we're going to do radians, right? Here's the radians. They already put them all in there for you. And so what is the sine? And let's just go through each of these values. And these are going to be, let's label them here first. These are the values on our x-axis. So notice I'm going up in increments of pi over 2. I'm not doing everything. Okay. I'm just going up in the pi over 2 increments. So I'm not doing the 3 pi over 4. I'm not doing the 7 pi over 6. Okay, I'm not doing all those ones. I just want you to get a general idea of what the curve is right now. And so what is the sine of negative 2 pi? Well, first of all, where is negative 2 pi? There's negative 2 pi. Oh, it's at 1, 0. So what's the sine of negative 2 pi? 0. So let's graph that. 0. All right, negative 3 pi over 2. Where is negative 3 pi over 2? Up here. So that's 0, 1. So what's the sign? 1. When I graph that, I'll put a 1 up here and a negative 1 down here. All right, how about negative pi? Well, negative pi is here. Negative 1, 0. So what's the sign? 0. Oh, we're back down at 0 again. So notice so far, if I'm starting to connect, this is going to be a curve. It's going to curve around like this. Now, I could fill in values in here, but trust me that it's going to be a nice little curve. All right, negative pi over 2. Well, that's down here. So that's 0, negative 1. So the sign would be negative 1. So I would graph it. So my curve is now coming below. How about at 0? Sign is just 0. So I go back through 0, 0. And that's 1 period. So my graph is now just going to repeat. At pi over 2, I'm back at 1. And then I'm here at 0. And I'm at negative 1 and 0 and 1 and 0 and negative 1 and 0. And so you guys can go ahead and fill in the rest of your graph. Okay, so it looks like a nice wavelength. So if we were to start picking values inside here, like if I picked pi over 4 and, hi,
Michael Lickowitz?
yeah, Mike, go ahead. And pi over 3 and pi over 6, right? And we have done that in the past where we've built the graph very specifically. If you start picking those values in here, you're going to see that they do indeed curve up along there. And same thing here, that they start curving down. So you get your root 3 over 2, your 1/2, your root 2 over 2, right? And it's going to start building, okay? So it's a nice curve. I need it to be nice and rounded. These should not be straight lines. They should be curved and rounded. And let's answer some questions about it. What is the period of our sine graph? 2 pi. Yeah, you can see 1 period length, right? From negative 2 pi to 2 pi, and then it's, or to 0, and then it's repeating again until we get to 2 pi. This is the one right here. This from 0 to 2 pi, that's sort of the main one that we always graph. When we're just asked to graph 1 period of sine, we usually graph this one in here from 0 to 2 pi. Okay, so our period is 2 pi. What's the amplitude? 1. Yeah, it goes 1 to negative 1, right? Divide by 2, so it's just this length right here. That's my amplitude. What's the y-intercept? 0, 0. What's the x-intercept? Plural. Yeah, so it's 0, 0. It's negative pi. It's negative 2 pi. It's pi. It's 2 pi. It's 3 pi. It's 4 pi. How would I describe all of these? Yeah, multiples of pi, right? Pi, 2 pi, 3 pi, 4 pi, etc. So how do we write that? Well, there's lots of different ways, but we're going to use that k again. That k just to multiply, to do multiples of. So, right, if you were kind of thinking it's like 0, 0, 0, oops, sorry, pi 0, 2 pi 0, 3 pi 0, etc. The way we would write this out is we would write pi k, comma 0. And now technically k is an integer, so if you want to specify that, you would say k is an element of the integers. And the integers we use a capital Z to represent integers. Craziness. Not yet, but in chapter 9 you will. So it's going to keep coming back, this k integer thing. So you're going to have to kind of learn this eventually. But so for now you can just write pi k. It just means multiples of pi, where k is an integer. In one period, where in one period does the graph reach its highest point? So look at this period, just this main period right here in the middle. Where does it reach its highest point? At pi over 2, comma 1, right? And where in that same period does it reach the lowest point? 3 pi over 2, comma negative 1. This was that question on your test about what's the highest value of sine, the lowest value of sine. Right, there it is, 1, negative 1. Right? Okay. So now, that's your graph. That's it. That's for sine. Okay? So what I need, if I asked you to graph one period of sine, is I need that one period right there. How many dots are there on that graph? There are 5, and I need those 5 points. That's what I'm looking for. So it's 1, 2, 3, 4, 5. Okay, all at pi over 2 intervals, up to 1, down to negative 1, and connect with a nice curve. Okay? Let's do the same thing for cosine. So let's go to the next one. And it's the same idea here with cosine, right? Let's just fill in our table, and then let's build our graph and see what it looks like. It's going to be kind of similar, but a little different. So negative 2 pi, let's start with that one. That's over here. Nope, just kidding. That's over here. There we go. So we're at 1, 0, right? So what's the cosine? 1. Negative 3 pi over 2, that's up top. 0, 1, what's the cosine? 0. Negative pi, that's over here. Negative 1. It's the same pattern, it just started off a little differently, right? So I'm at 0, negative 1. All right, so you can fill in the pattern. 1, 0, negative 1, 0, 1, 0, negative 1, 0, 1, 0, negative 1, 0, 1, 0, negative 1, 0. And then go ahead and graph it. Hello. Silence your phone, please. All right. Does yours look like that?
Sure.
Good. Same idea. It's going to be nice and curvy. If we were to pick values in those spots right in the middle there, right? If we were to pick pi over 6, you know, we'd be at root 3 over 2. And if we were to pick pi over 4, we'd be at root 2 over 2. And then at pi over 3, you know, we'd be at 1/2, right? So you would see these gradually going up and down. Yeah, Berto. Yeah, why is it curved and not straight? Yeah, because it's not going at it's not like a slope. It's not like a straight line. It's not like even intervals, right, that we're going down. It actually does curve around for these.
What does it?
How do we get those? Is that like
Oh, that's nothing we're gonna ever graph. Yeah, don't worry about those guys. That was just an
Not graphing
example.
the-
No, that mountainy one. Yeah, no, we wouldn't do that.
But when would it be for that?
That would be like some transformation of an absolute value graph. Yeah, so that's not something we would do. Okay? Yeah, good questions, you guys. Those were just examples to see like what was a period and what was an amplitude. Okay. All right, so answer some questions. What's the period of cosine? Yeah, it's 2 pi again. And again, when we're looking at what is sort of the important period here, if I just asked you to graph 1, it would again be this one from 0 to 2 pi. Okay, so this section right in here. So notice it starts up here at 1 and then goes down and back up. It kind of looks like a U, right? Or, I don't know. Some people have called it a tongue before. I don't see it. Amplitude would be, you see it? What would my amplitude be? 1 again, good. Y-intercept this time is 0, 1. X-intercept is? So x-intercepts are a little different this time, right? What are my x-intercepts? Let's start listing them. Pi over 2. Yeah, and then 3 pi over 2. And then 5 pi over 2. So, how would we write that? Yeah, with the k in there, right? So you can do it the same way. Should I have this written? Oh, I'm trying to see where I wrote it last time. Okay. And that where k is an integer. All right, where in one period does it reach the highest point? Yeah, it's kind of 2 places, right? At 0, 1 and 2 pi 1. And the lowest point would be in the middle there at pi negative 1. Okay? So for your quiz tomorrow, literally it's 1 minute. Yeah, and you just have to graph one period of each one. So you have to graph that part of it right there for cosine. And I need to see those 5 points. You need to label your axes. That's going to be the important part. So you label the axes, 1 and negative 1, which I didn't even do there.
And we only have 1 minute?
Yeah, so 30 seconds to do that one, and 30 seconds to do that one. Do you want to practice right now?
Yeah.
Okay, good. Take out a blank sheet of paper. We'll practice.
I said no. She said good.
And I said
okay,
good.
Let's take out a sheet of paper.
Let me stop my video. They don't.